Hello, everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about using Lakehouse monitoring and data observability to deliver enterprise data reliability. Our sponsors today are Databricks and Excel Data. For our presentations today, we'll hear first from James Kobielus with TDWI. And after Jim speaks, we'll be joined by Pradeep Anandapu with Databricks and Ramon Chen with Excel Data for presentations and a panel discussion. Before I turn over the time to our speakers, I'd like to go over a few basics with everyone. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, you can click on the Technical FAQs area and you'll receive technical assistance. If you'd like a copy of today's presentation, please locate the resource window to download the PDF. And lastly, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share with a colleague. Again, today we're going to be discussing using Lakehouse monitoring and data observability to deliver enterprise data reliability. And our first speaker is James Kobielus. He's the Senior Director of Research for Data Management at TDWI. Jim is a veteran thought leader, industry analyst, consultant, author, and speaker on analytics and data management. Over the past 3 decades, Jim has held analyst positions at Futurum Research, Wikibon, Forrester Research, Current Analysis, and the Burton Group. He also served as Senior Program Director for Product Marketing for Big Data Analytics for IBM, where he was both a subject matter expert and a strategist on thought leadership and content marketing programs targeted at the data science community. At TDWI, Jim focuses on data management, which encompasses database platforms, data governance, data integration, master data management, data ops pipelines, and more. Welcome, Jim. And with that, I'll hand it over to you now.
Thank you, Andrew. I hope everybody's having a good day. Yes. So we're going to be talking about, as Andrew indicated, using Lakehouse monitoring and data observability to deliver more reliable data into your enterprise, into every application, decision support scenario, every analytic application, and others that use data, and everyone does now. So, you build your business on data, you run your business on data, and to deliver the best outcomes in terms of the best decisions, the most efficient processes and the like, what you need to do is make sure that you have a highly reliable, high quality, trustworthy data feeding into every application. And increasingly, organizations are consolidating, converging their data platforms onto something called a lakehouse. That is a convergence of both your data lakes and your data warehouses. And so what you need to do if you're, like everyone is, running your business on the best data and the best analytics, you need constant monitoring of the pipelines through which data is ingested, prepared, cleansed, and delivered into applications. You need to be able to track the quality of that data and also be able to diffuse or preempt any issues in the data pipeline that can keep the data, the highest quality data, from being delivered downstream to where it's needed. And that requires tools known as enterprise data observability tools. So we'll be discussing those today. So, in terms of level setting, like I said, the data lakehouse is increasingly the core data platform in many organizations. And data lakehouses are a convergence point for driving a wider range of analytics into every enterprise application. So like I said, it's a convergence of your data warehouse, which of course is your traditional data platform for business intelligence, decision support, enterprise performance dashboarding and the like, and your data lake, which is your data platform for data science, advanced analytics, artificial intelligence, and the like. So the data lakehouse, the convergence of these two platforms, provides a unified view of data and analytics assets in your throughout your enterprise. It provides a point for converging the pipelines for both data and analytics, your data ops and your ML ops pipelines. It provides a unified experience for every knowledge worker, every data scientist, everyone, to access, analyze, manipulate, and process all of that data. It provides a platform for unified management, monitoring, observability, optimization of data and analytics, and the pipelines and processes involved in putting all that data in shape. And it provides a unified abstraction for programming, cloud native microservices that provide data and analytics into the full range of enterprise applications. So the data lakehouse is a very important platform for running your business. And data observability, making the business case for data observability, data monitoring, is fairly clear cut. What it does, observability, is it automates the roll-up of your view into the data's provenance, its lineage, where it's being processed, how it's being processed, how efficiently, where the data is located, how it's being moved from one platform to the next. So you can improve that, you can monitor the data's processing throughout its entire life cycle. It enables you to augment observability assessments of data's reliability, completeness, consistency, and accuracy everywhere throughout your enterprise data estate to ensure that the data is always consistently of high quality and trustworthy for all manner of downstream uses. Observability enables you to accelerate responses to challenges that hinge on data's reliability, transparency, and explainability, such thing as data compliance mandates, to prove that you're managing that data in accordance with all the relevant laws and regulations. Observability provides the tools to assure your stakeholders, your employees, your customers, your partners, and others, that high quality data is being delivered consistently everywhere where it's needed. So you can guarantee that users always have access to the best data and the best analytics for that matter. So observability is a tool for assisting organizations in understanding their data status at any time. So you know exactly where, in what condition, and in whose possession data always is. And last but not least, observability provides the ability to anticipate issues in the data pipeline before they can jeopardize key business metrics. In other words, enables you observability, high quality observability tooling, enables you to resolve issues with data processing and governance before they can jeopardize the quality or disrupt the operations and the processes that depend on data's consistent delivery downstream and its best fit data for all purposes. So delivering actionable data observability is critical for many stakeholders. For data engineers, observability enables them to view the data pipeline flows to make sure that everything is balanced and flowing with low latency from end to end and as efficiently as possible. IT professionals rely on observability tools to visualize the price performance, for example, of alternative data ops architectures, so to help improve the efficiency and the effectiveness and reliability of the pipelines through which all of that data is being processed. Your executives are trying to determine whether the data investments that your company is making are aligning with business priorities. Observability tools help them to understand whether these data investments are in fact delivering on the key performance indicators that are incumbent upon your data and analytics applications in terms of running the business. Your BI developers rely on observability so they can investigate the root cause of anomalies and issues with the data presented in, say, performance management dashboards and the like. Your data analysts rely on observability to assess the lineage and impact of errors in business intelligence reporting. Your data stewards, who manage data quality processes, they use observability to spot and resolve quality issues with the data before they can impact the business, so they can take effective action to keep data cleansed and consistent and compliant everywhere in your organization. Your data architects rely on observability so they can view cross-system data dependencies among the various linked business processes to make sure that the data that's being provided into and fed into all business processes is consistent and cleansed and correct at every point in its life cycle. Last but not least, data scientists rely on observability to detect data changes that might signal model drift, so that they can take action to retrain models to keep them fit for purpose and deploy, so they can be deployed for downstream inferencing with a high degree of confidence. So observability, instrumenting your data ecosystem for observability, of course, in a lakehouse environment, requires that you provide the ability to monitor data pipelines, flows, workloads, and metrics across distributed environments. You want to configure your data observability tooling so you can visualize, predict, detect, and resolve issues with data reliability in near real time with low latency. You need observability infrastructure that can automate correlation analysis, tracking and logging of data events, issues, and anomalies. And really, there's a broad range of tools and interfaces and applications through which data observability intelligence is delivered downstream to its stakeholders. Visualizations and analytics. There are APIs for programming interfaces between your IT systems management tools and your data observability environment. Data catalogs are an important component of the observability stack, as are metadata management, data profiling, data quality, and alerting capabilities. And really, data observability tooling to be truly effective in today's complex data and analytics environments and cloud computing environments, these tools need to be platform agnostic, low latency, available on demand and in real time. They need to be able to scale and adapt to the distribution of data and analytic workloads across increasingly complex hybrid and multi-clouds and edge environments. The observability tooling needs to be able to auto-generate data quality rules so that your overworked, overstretched data stewards don't have to do every single process in terms of rule authoring and administration manually. You need configurable alerts to alert your stakeholders to issues that may be taking place or are threatening to take place in terms of in the pipelines, in terms of the data processing, in terms of data quality issues and the like. So using intelligent observability is very important, and we really need to drive machine learning into every point in the observability pipeline. Machine learning can validate data as it's ingested, can learn pipeline traffic patterns, correlate pipeline events, identify root causes, remediate issues automatically, optimize pipeline processing continually, and really provide the capability to deliver embedded recommendations within the various tools that your data engineers, data stewards, analysts, and others use to monitor the data pipelines and quality that are of interest to them in doing their jobs effectively. So automating through embedded intelligence provided by machine learning is critically important to being able to scale up your observability infrastructure without having to hire new people, but rather to be able to allow your existing data staff to work more effectively, since more of the processes that are repeatable, that can be automated are being. So I'm going to hand it back to Andrew. He can introduce our panelists.
Terrific. Yeah, thank you very much, Jim. Our next speaker is Pradeep Anandapu with Databricks. Pradeep is a senior partner solutions architect at Databricks, where he works on the core dev and product partnership team. He helps build and evangelize technology partner integrations on the Databricks Lakehouse platform. And with over a decade of experience in the data and analytics field, he continues to be a data nerd. Welcome, Pradeep. And with that, I'll hand it over to you.
Thanks, Andrew. Right. And thanks, Jim. That was a really good overview. I'm going to cover a little bit about Databricks today and touch upon observability and how Databricks is handling that or solving the challenge. So Databricks is a Lakehouse company. We are the inventor and pioneer of Data Lakehouse. We created Delta Lake, Apache Spark, MLflow. What's unique is we are recognized as a Gartner leader in both database management systems and data science and machine learning platforms, which is, of course, what makes us a Lakehouse company. Let's go to the next one. So as you all know, I mean, companies have been focusing on data for years, and everybody wants to use data in every part of their business. That's what we call a data forward enterprise, right? For companies to achieve that, they were previously struggling with data silos, but we have seen a pattern where most of the companies are sitting in the state that I show here, where things are getting better, but data is still not driving their business. When we look into it, what we found was, most of the organizations, they're trying to set up platforms, different platforms for data lakehouse, data warehousing, orchestration, business intelligence, data science, machine learning, streaming, governance, etc. So to stitch together all of this, and on top of that, because the topic of the day is observability, being able to observe and monitor data going through all of these platforms becomes extremely complex. And it is a hard problem to solve. And that's what Lakehouse is set to do. Lakehouse basically takes a different approach, right? Like Jim covered, it's a combination of both data warehousing and data lakes. It's the best of both worlds in a sense, right? So you have all your structured, semi-structured, unstructured data sitting on one platform with one security model for data access across the organization. And this platform should support all different types of modern workloads, BI, data warehousing, data engineering, data streaming, and then data science and machine learning. So Databricks today is the only unified lakehouse available in the market. There are other platforms that are catching up, but Databricks is the one that kind of solves all these all the capabilities that I spoke about in the previous slide. So we do that by first of all with Delta Lake, right? I'll let you know that we are the creator of Delta Lake. And what that does is it's now able to not only do data engineering or like machine learning or data science on data sitting on cloud, on cloud like AWS, Azure, or GCP, but also do perform data warehousing workloads on the same data. So you don't need to put your data in some proprietary data format or anything like that. So with the open source Delta format, you're able to perform data warehousing workloads. So that's the main thing that it uncovers, right? And then Unity Catalog. With Unity Catalog, you're able to now govern assets, both data and AI assets. And across the organization, you should be able to discover data and then be able to access it. Now, on top of that, of course, all of our compute, we're able, with Databricks SQL, we're able to cater to data warehousing workloads. We have Databricks workflows for orchestration, Delta Live tables for data engineering, and we got Databricks ML. So that's the Databricks platform. And when it comes to observability, how we are solving it is with system tables. So on Unity Catalog, you will be able to find system tables on Databricks, which basically unify all the observability, data observability, system observability data. It's basically anybody in the organization could just access this data and start monitoring the quality of the data and ensuring the data is reliable for their particular workloads. So that's how Databricks is solving it. And of course, unifying it is a challenge. We currently have billing, audit, lineage, and pricing tables available. I did put a link on the Q&A, but more tables are coming in, and you should be seamlessly, easily able to consume all this data. And some of the data sets come with their own dashboards and stuff like that on Databricks. So you should be able to monitor your metrics and stuff. Now, of course, Databricks is a platform, and we have a strong ecosystem. And Axel Data is one of our partners, and a really good data observability partner. And you can see them here. And so with the system tables being unified, now partners like Axel Data, they don't need to go into different parts of Databricks platform to extract this data observability information. They could basically just go to the system tables. Of course, they do additional things on top of that. But our job is to make it easier for data observability platforms like Axel Data to easily consume that observability data from our platform, right? So that's what we're doing, and we have a strong ecosystem of partners built on top of it. So overall, Databricks, of course, the best data platform, and the best data platform is the Lakehouse, and it basically proves that, right? Also, an icing on the top, it really lowers the costs and basically drives faster innovation. We have seen this across the board, across several companies, organizations. So yeah, thanks. I'll pass it on to Andrew.
Terrific. Thank you very much, Pradeep. Happy to introduce our next speaker today, who is Raman Chen with Axel Data. Raman is the Chief Product Officer at Axel Data, and he brings more than 3 decades of enterprise product and marketing leadership experience. Raman is a widely read blogger and speaker on data observability, master data management, big data, AI, and cloud computing. A former software engineer, he has spent his entire career developing and marketing enterprise software, helping create market categories that solve enterprise business challenges while establishing the companies he represents as leaders. He graduated from the University of Essex with a bachelor's degree in computer science, specializing in AI. Welcome, Raman, and with that, I'll hand it over to you now.
Thanks very much, Andrew, and thanks very much, Pradeep and Jim. I'm delighted to be here today. 3 decades doesn't sound as good as I feel right now, but nevertheless, it gives me sort of unique insights into the topic I'm going to discuss today on behalf of Axel Data. So let's see. Well, so I think where to start is, why did Axel Data originate this term data observability? Well, our founders and our CEO were essentially observing the evolution of data management, as Jim quite eloquently described. And the trend was increasingly more data, more technologies, and there was a focus already on observability, but it was very narrowly focused on individual tools, observing how the behavior of master data management worked by reporting in that regard, observing how data quality tools work, reporting on the functionality within data governance. And so all of this was siloed. And as the evolution of the modern data stack from around about the 2015 timeframe, the explosion has just continued. So our founders and our CEO, Rohit Chaudhary, realized that something was required in order to give a holistic view on all of this sort of chaos that was occurring. Things were happening well, but within their silos. So Axel Data was formed, and the concept of data observability was developed. So what is data observability aiming to solve? As I mentioned, exponential data growth, system complexity, but increasingly, one of the things that is almost an unspoken truth is the lack of talent, data engineering talent. Jim mentions all this time people are spending focused on data quality. They need some level of automation. The stewards are struggling. Something had to be done and is being done about the lack of talent, not to replace people's jobs per se, but to give them the ability to focus more on things that drive the business rather than the rote work of having to do and manage data quality rules, functions, and continuously keep a manual eye on the state of the data across the systems, and to prevent being blindsided essentially by things and incidents that occur. Of course, enterprises want to be AI and data first, right? You can't sort of open LinkedIn or any news outlet and not hear about Gen AI. We all use ChatGPT, I'm sure, and Bard and Claude. But really, it's all about three things: wanting to operate and execute reliably, wanting to improve data reliability or data trust, right? The trust in the data. Many of our customers came to us because they don't trust their data, right? Despite the availability of data quality tools and all sorts of governance, there's still this level of mistrust about the accuracy of the information that's either being used for compliance or real-time business decision-making and execution. And ultimately, it's about scaling and modernization. Databricks is a phenomenal platform, and they keep adding increasing capabilities, which is fantastic, but that means different factors and different views of what you'd have to keep an eye on. And as there's more functionality and more capabilities, there's more things that could break. And this is also leading to a lot of busy work, a lot of administration, a lot of configuration, and that's not really scalable. So just a quick thing about Excel data. As I mentioned, our founders sort of incubated this concept, and enterprise data observability is what we focused on. Technologies for the largest of companies which have huge data problems. We were founded in 2018. Our leadership team comes from a variety of disciplines. Myself personally, I was the chief product officer at Reltio, the leading cloud data management provider. We've raised over $100 million in investments, and then we have some marquee customers, a very small partial list that's represented here. One of the really great things and exciting things I love about what we're doing is we're dealing with petabyte scale data. In fact, we just crossed half an exabyte of data under observability. That's a phenomenal number. The mind boggles as far as I'm concerned, having been in the business all these years. But the scale of what's happening and the amount of data that's being processed is truly mind-boggling. So just a few sort of descriptions of what we do and the kinds of things that we solve in terms of our actual platform and technology. We're all about the business problem, right? We can have, a beautiful architecture with a lot of capabilities and a lot of technical features and functions, but ultimately, what are the business problems that we're solving? The one that's top of mind right now, and it's top of mind for everybody, is cost, right? In these challenging times, the supply chain is full of inefficiencies, redundancy, over-provisioning of licenses, poor utilization leading to unnecessary execution of particular jobs, overrun processing, quality that's not being addressed, and I'll cover more about that in a second, and then the selection of continuously managing and swapping out this sort of enterprise scale set of best-of-breed tools that cover the large enterprise landscape. All of this is a financial burden. And the question is being asked, where are we going to find all this money to invest in AI and Gen AI? Reality is, to use an analogy, if you want to look under your seat cushions within your own enterprise, there's capabilities and efficiencies that you can squeeze out in order to redirect that money into these AI initiatives. So we can talk a little bit about how we can do that using data observability. The enterprise data grid is not stable either. What do we mean by that? It's very brittle, unfortunately, because there are so many pockets of siloed tools and execution, and things are, we're trying to make these improvements with data fabric and the concepts of data mesh, but we're in the infancy. And in order to even get to this notion of what should we be doing with a fabric or a mesh or creating data products, which everybody wants to do, and not to mention monetizing data, which we can talk about some other time, first thing is you've got to know what's going on in your existing data landscape. What's the health of your data? Many of our customers come to us not necessarily because they already have problems, but they don't know the problems that they have. And so data observability, and what you see here is just a partial set of capabilities that data observability focuses on, all the way from schema drift to the health of your pipelines to really looking into your data quality and data reliability, and then this notion of data reconciliation, which is not done by existing data quality tools. And we can talk about that in a second in the Q&A if everybody's interested. But all of this is manifesting itself and disrupting, but it's all about insight and visibility. Data observability, as the term connotates, is the necessary precursor to understanding what you have today so that you can add new tools, so that you can make existing tools better. And that's generally why data observability is becoming extremely popular today. So again, Excel data delivers what Gartner would call the 5 pillars or types of data observability. And we're one of the only vendors that can cover all 5 of these areas. First of all, starting from bottom left, all the going around the wheel here, data reliability, absolutely critical. And I saw a question about what's the difference between data reliability and quality. Data quality, I'll answer that during the Q&A. But then it's about data in motion, real-time data, flowing data through thousands and thousands of pipelines. When your schema changes, schema drift, all of those things. How are you best optimizing your infrastructure and compute workload? How are you optimizing Databricks and using it to its full capacity? And then how much is that costing you? And how are you going to allocate the costs and your investments through chargeback, forecasting, and budgeting? And ultimately, your users are a key part of the platform. What is their behavior? How are they actors within the data flow? And all of that is critical. So Databricks and Excel data, as we mentioned, we're partners, and we're delighted that the Unity catalog is evolving and maturing, and the system tables that Databricks is delivering through Lakehouse Observability and Lakehouse Monitoring is really going to help further improve what Excel data is doing in regards to data observability. But today, we already created a version of our platform, which is completely available today for spend intelligence, understanding how you're using operational intelligence, understanding how you're using Databricks in the context of your flow, as well as all of your other heterogeneous tools. The ability for us to tap in to the Unity catalog and the system tables, and we've been partnering with Databricks to build out what we need to see in order to make it even better. And so we're delighted to be involved in this partnership. So to close, why is Excel data different? I think data observability is a very misused term right now, and it's leading to confusion in the marketplace. Really, what data observability is the holistic view of all of your data across your entire enterprise, the health, the reliability, the consumption, the spend, and all of the rules and alerts and the remediations that you can proactively put in place to ensure that your business gets the best use out of your data. Excel data is unique because, as James mentioned, we can cover any cloud, any data source across this data journey. But enterprise really means that we also support on-premises. You know, many people kind of tend to forget that there are large systems still operating in non-cloud environments, and they do want that data to be migrated eventually. And that's critical as well. From an enterprise perspective, as you would expect, we have high degrees of security, we're low no-code configurability, and of course, exabyte scalable, as I mentioned. And then finally, one of the ways to start with data observability is to look at your compute and spend optimization, as I described, and that can be implemented rapidly to deliver immediate ROI. So thank you so much for my little section here. And do visit exceldata.io/databricks and hand it back over to Andrew.
Terrific. Thank you very much, Ramon. Now it's time for our panel discussion, so I'll ask that both Jim and Pradeep rejoin us. And Jim, I'll hand it over to you to begin the discussion.
Thank you, Andrew. Great presentations, both of you gentlemen. I'm going to start with you, Ramon. You made it, well, there's observability, there's data observability, and there's enterprise data observability. Could you summarize what is enterprise data observability versus data observability writ large?
Yeah, so as I mentioned, I think data observability, the term has been kind of polluted a little bit. But, there isn't a crystal clear definition yet. So Gartner, Forrester, and the like, and yourself, James, have great definitions. But people are somewhat viewing data observability as a bolt-on, right? And I describe this in a sense that you're seeing a lot of data quality vendors or data governance vendors offering data observability. But data observability is not an adjunct or a supplement to data quality. It is a complete umbrella at scale, looking across all of the tools and pipelines as you had described. And what connotates enterprise, in my mind, is volume, velocity, variety, and stop me if you've heard this before, and veracity, right? The 4 V's of big data. And the reason why enterprise data observability is key, and the reason why I'm very proud that we've hit exabyte scale in terms of the amount of data observed, is this notion of shift left, right, to the beginning, which you had described, the beginning of these data source and pipelines, because the amount of data that's going to have to be observed at the beginning of these pipelines is enormous, right? It's 10 to 100 times the volume before it reaches its destination. And at enterprise scale, this is what we're talking about. The other aspect, which I did mention towards the end of my slot, is enterprise means not just the sexy new cloud technologies. The modern data stack really needs to encompass the legacy platforms. Otherwise, it's not true enterprise.
All right. Pradeep, care to add anything to what Ramon has said?
Yeah, I mean, I think Ramon has covered it pretty well, but basically coming from a Lakehouse point of view, for us, it's mostly about being able to achieve that across all workloads, right? For example, streaming is a complex one to achieve. Data science, AI, these workloads are pretty modern, and Databricks is trying to solve that and unify that along with the other, other observability it already provides, right? So that's what's key for us. So basically, end-to-end, being able to monitor health and quality of the data from ingestion to consumption. That's what we look at.
Okay, great. So we'll move to the next question. Metrics or key performance indicators. What are the principal metrics for data reliability that organizations should use data observability to help them monitor, assess, and manage? Either of you can start on this one.
I'll start, Pradeep, if that's okay. So metrics are interesting because I would say there's the typical technology metrics, which could include the number of rules that you've defined and are actionable within your data observability framework. Some companies, as we do, provide a data reliability score, which is a good sort of holistic, universal roll-up and measure of all of the things that's going on, including schema drift and all the features and functions, freshness of the data. But really, it boils down, in my opinion, the metrics that every organization should be measuring, in addition to those technical nuances, are the business impacts, right? So our customers think of the metrics, yes, from a technical perspective, but what they're keeping an eagle eye on are the number of incidents that might have occurred had this not been put in place, and is that trending down? The amount of hours freed up from people who have to spend their time, as you again, quite eloquently pointed out, Jim, managing these rules and continuously worrying about, is the data good or is the data bad? One of our customers said, every weekend my pager goes off because there's some incident going on. How am I going to get my life back, right? This is something has to happen. So the business metrics and some of the other metrics could be accuracy of compliance reports. Our technology is used a lot for that in the financial services and financial regulatory and compliance. So business focus, but I think there's an opportunity finally to get a 360-degree view of all of the health of the data across governance, across data quality, across everything that's been invested, and really tie that to business value, right? I think that's really the missing link, and that's what we're all working towards.
Pradeep, care to add something Ramana said here?
Yeah. I think that's great, Ramon. That adding governance to that view is incredibly beneficial. But so how I see it is, you get some outputs from observability platforms, right? You got freshness, quality, volume, schema drifts, and lineage. All this data is available now. A data platform, data observability platforms like Axle Data, they have some predefined stuff on top of it as well, that are defined. But what's most important is for the people to come together across the organization to be able to define these metrics, right? Like how do they define data reliability? What will be the definition of trust be for them, right? So this is a huge challenge, and this is a people challenge and a process challenge, and that's also very important while defining these metrics. So that's what I would add.
Very good. Move on to the next. Scalability. Data lakehouses and data ecosystems in the cloud continue to scale out. How should enterprises deploy data observability so that it can scale up and out it with the data ecosystem that's being monitored and managed? Scalability.
Awesome. Pradeep, you want to go first on this one?
Yes, I can. So from a Lakehouse standpoint, right? Just when you're choosing a lakehouse, of course, you want to make sure this lakehouse has the capability to be able to provide unified observability information. That is key. Otherwise, it's really hard to look into your data and your workloads. So from that's from the lakehouse perspective, right? But when you're choosing a data observability platform, like although Databricks Lakehouse has a lot of capabilities from an observability standpoint, we also have Lakehouse monitoring, for example, right? But it's catered to Databricks, right? It's catered to Databricks Lakehouse. Now, everybody understands that in enterprise there are several data platforms. Data is flowing all over the place, everywhere. So choosing a right data observability platform means this platform should be able to connect to various data sources and be able to piece all those two pieces together and be able to provide end-to-end observability no matter the platform. So, and of course, do it at scale because, these days data is at, petabyte scale or exabyte scale, like, Ramon was talking about, right? So that's what I would say. So.
Yeah, fantastic.
Your thoughts?
Yeah, so what Pradeep said, he could be the ambassador for data observability. And, I just want to plug Databricks one more time here. Databricks is an amazing platform, one of the best, if not the best, in the new data management landscape. And but they're an open platform, and the proof is in the pudding with the Lakehouse observability and monitoring, and the system tables that they're providing and partnering with us and other vendors out there to deliver what the enterprise needs. So they're not myopically focused on their platform. They're doing exactly what Pradeep described. So all credit to them. Yeah, I think really the question here is, how can you ensure that you have coverage across a diverse ecosystem? First of all, to go back to my point, you need an enterprise data observability platform, which also covers, and I can't stress this enough, the legacy. There's tons and tons and tons of Hadoop systems on-premise, legacy systems. In fact, there's AS400 sitting out there. I used to work on those back in the early 90s, dating myself. These are still very, very important. And I think universal coverage and the ability to cover all of these components is critical.
Very good. Let's move to the next. End-to-end observability. So how can enterprises deploy data observability so that they can issues at the source of the problems? In other words, at the source systems, be they ERP or CRM or some other application, before the data is being fed downstream. Does observability require that there be like an observability agent deployed in all the source systems? Can you do observability through a proxy architecture? How do we identify and really stamp out reliability issues at the source?
I'll start, Pradeep, if that's okay. The architecture of an enterprise data observability platform, which, shame on me, I didn't mention, needs to be able to flex to the architectures within an enterprise, on the cloud, in the cloud, running a data plane within their infrastructure, in VPCs, in a multi-tenant environment, running on-premise. This is the nature of data observability. You have to be where the data is being sourced, where it's being produced, and the rules and the recommendations and the alerts and the observability capabilities all have to function in the architecture and comply to the regulations, right? The reason why Excel Data has so many financial services customers are that we can provide exactly the functionality they need within their compliance framework. Now, the whole notion of how can it be done, this whole shift left, right? Visualize a data pipeline. This will somewhat answer the question on data quality versus data reliability. A pipeline starts with a whole morass and source of data, as you'd seen in my previous diagrams. Now, that data is at scale at source, right? And typical data quality systems are addressing the remediation of poor data quality much further downstream and not necessarily at streaming, as Pradeep pointed out. And because of that, that's one of the main differences, right? Not to say that data quality is not needed anymore. In some cases, they have been replaced. Some of our customers have replaced legacy data quality tools, but ultimately it's about shifting left. Now, how can enterprises do this? Start small initially. I wouldn't boil the ocean. And I think actually there's a question coming up around sort of that process.
Pradeep, your thoughts?
Yeah, I do think that shifting left is the key here. Basically, imagine, in an organization, if you're trying to, if you say, hey, this data doesn't seem right, it's usually reactive where, oh, I do see some data quality issues here, or like, it seems like data arrived late or something like that, right? But organizations will be able to, just mitigate that issue at that point, or like, just be reactive to it. But when all stakeholders come together and then implement solutions to be able to resolve that issue or proactively, as in, if there is a data quality issue, what do you do that? Like, do you detect it at the time of ingestion, and maybe somehow fix it, or throw it into exceptions table or something like that, right? Like just at a very tactical level, That's how you need to think about it. If you don't create these solutions, then you'll always be reactive. Yes, you have a data observability platform, but you should be able to improve your metrics and do that proactively. That's what I would say. Yeah.
Great. One more panel question before we move to audience questions. So collaboration among stakeholders, chief data officers, data engineers, scientists, around the need to maintain data reliability. So within an observability architecture, how do collaborative capabilities enable teams to work together to make sure that you're constantly hitting these objectives in terms of quality and reliability?
So I have a quote prepared. So I read an excellent article by Ellen Nielsen, the Chief Data Officer at Chevron. And she wrote recently in the CDO magazine on the topic of data maturity. Maturity in data is like a fine wine. And in that, she has this great quote that data maturity is not a top-down initiative. It requires active participation and engagement at all levels. And that's what also, as Pradeep had pointed out, the collaboration and the holistic visibility across all the stakeholders is absolutely 100% key. So the chief data officer is under fire, in addition to what Ellen describes as generating a data maturity scorecard to find out where you are. And data observability can help with that because now it gives you a lens and a health check of your state of the union. But because data observability is a continuous process, once plugged in, it continuously observes. You don't have to take snapshots of where you are in your data maturity, right? And in fact, a lot of the data maturity and collaboration is done through surveys. Do you understand this? Do you, are you aware of this piece of information? When you have the observability framework, you don't even have to ask. You can see who's touching the data. How's the data flowing? Which stakeholders are involved in various stages of the pipelines? So it all starts, I think, with a holistic tool. Now, obviously, I'm a little biased, but that's why I'm at Exceldata. In the 30 years, and I've done MDM, I've done databases, I've done applications. I joined because we're at a seminal point where we finally can get the answers that we were looking for. The silos need to be broken down, and it's happening now in real time.
So universal observability keeps everybody up to speed on who's being impacted and who's doing what to respond to or proactively diffuse issues with the data pipeline. Great. Pradeep, anything to add?
Yeah, I think, James, you just covered that, right? So basically, you should start by, organizations need to start by, defining roles and responsibilities, and then establish standards and processes, that they want to implement on top of this data observability platform. So so that's what I would say. That's the, they need to start with the org structure. Yeah.
Very cool. So we'll push it to Andrew now. This concludes the panel. Andrew, we have audience questions, so let's roll into that.
Perfect. Yeah, thank you all for that great discussion. We'll jump into audience Q&A here. And Rahman, I'll start with you. You actually called out one of these questions earlier, so I'll go ahead and give it to you now. What is the difference between data quality and data observability?
Outstanding question, and I believe this is coming from Nilesh. Traditional data quality, as I may have touched on, is something that was born out of the relational database era, right? And the focus was how to fix data when we see bad data. It has since been morphed and enhanced to include rules and some form of better digestion and remediation. There have been attempts to extend it to touch more and differentiating modern data sources. But the key thing is this whole shift left paradigm. Data quality functions have never been designed to operate at this level of scale, right? As it was architected, it just stands to reason, right? When you were dealing with Oracle and MySQL and those relational databases, the volumes were nothing in the realm that we're seeing today. So when you think about data observability and shifting left, the sheer scale on the left-hand side of the data that's coming in just cannot be handled by traditional data quality methods and means. But more importantly, data quality is now more a subset of the overall what we would call data reliability. And data reliability means not just is the data bad or is it wrong, but am I getting the right data because of data freshness, right? And is data missing? Is all of a sudden a source missing? Data quality is not designed to say, I'm missing some data. It's designed to say, I need to fix data that I see that's incorrect, right? So there's a matter of not just scale, but there's also many, many different things that fall under the umbrella of data reliability, like schema drift and things like that. So I would love to give you a more sort of feature by feature nuanced discussion. Feel free to reach out. But at a high level, it's really about, the differentiation of what existed, 10, 15 years ago, even 20 years ago, and the reality of the situation today.
Okay, fantastic. We'll move on to the next question here. Pradeep, we'll go to you. So what operational data can I find on Databricks system tables today?
Yeah, I think I answered it there. So basically, I provided a link, in the Q&A. Today we have billing, we have lineage, we have basically column level and table level lineage available. We have audit logs that are also available on the system table. We recently added pricing and marketplace listings, and more tables are going to show up, like jobs, metrics, et cetera. So yeah, most probably in the next few quarters. So. Yeah.
Okay, thank you for doubling down on that for me. Last question here. I'll leave this open for either of you to answer. What is the query performance of ETL considering overhead of data observability?
I'll go ahead and answer that question. So thank you again, Nilesh, for the question. Overhead is an interesting word, right? So obviously there is some additional processing that needs to take place. Observability doesn't come out of nowhere, right? It's got to use some level of processing. But it is a minimal impact to the throughput, at least at scale, and the way we've architected how we do data observability at Excel Data to the ETL or ELT processes. The way to think about it, though, is more holistically about what's the penalty that you're facing right now not having data observability. The reality is that bad data is flowing downstream or incidents are occurring. And quite simply, the scale and the volume of data, because one of the things that data observability can do is it can decide and help you quarantine bad data. It can actually allow you to remediate and have higher quality data at scale compared to traditional data quality. So one of our customers could not run their pipeline end to end. It would take them weeks. And now they're doing it in less than 24 hours, which is, that's just business imperative, right? So I would think in terms of not what is the overhead, but what is the actual holistic benefit of inserting data observability into your pipelines, and net, you will ultimately benefit.
All right, fantastic. Well, unfortunately, this does bring us to the end of our time today. So please allow me to thank our speakers. We did, of course, hear from James Kobielus with TDWI, Pradeep Anandapu with Databricks, and Raman Chen with Excel Data. We'd also like to thank once again Databricks and Excel Data for sponsoring today's webinar. Please also remember that we did record today's webinar, and we'll be emailing you a link to an archived version of the presentation. And if you'd like a copy of today's presentation, please locate the resource window to download the PDF. Lastly, I'd like to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. From all of us here, let me say thank you so much for attending. This does conclude today's event.